Now, how PWM signals are generated? PWM signals are generated through microcontroller via the use of microcontroller pins. Use of microcontroller pins and toggle them from high to low voltage signals to produce the signals of this nature. These PWM signals are then fed to different external devices like LEDs, motor drivers, MOSFETs via the connection of microcontroller pins to these devices to vary the voltage and current around them. As on varying the voltage and current, the power delivered to these devices is changed, which ultimately changes the brightness or the motion of these devices. PWM signals in microcontrollers are generated via the use of timer peripheral of them. Timer peripheral has a concept of counters, and there are generally three types of counters in timer peripheral. Two counters have a fixed value and one counter would be incrementing or decrementing. Let's name the fixed value counters as max counter and the threshold counter, and let's have a last one as a var counter which would be changing its value. Now how things work is we equate a value to the max counter and the threshold counter during the initialization of PWM feature of timer peripheral of MCU, and the value has to be equated such that the threshold counter value is less than the max counter value. And when we start the timer peripheral, the var counter would start incrementing from 0 value to the max counter value, and when var counter is started from 0, the corresponding microcontroller pin is made to start with a specific voltage signal or high or low voltage signal. When var counter reaches the value of the threshold counter, the voltage signal of the configured microcontroller pin is changed. And after that, when var counter value reaches the max counter value, again microcontroller pin value is changed and var counter resets to 0. And then this cycle keeps on going. So var counter will count till max counter, and after that its value will reset to 0. And on reaching, starting from 0, it will start incrementing, and on reaching to the threshold value and the max counter value, every time the state of the microcontroller is changed, and this cycle keeps on repeating to produce the continuous flow of PWM signals. To understand from an example, let's say we equate a max counter value of 1000 and var counter starts incrementing from 0 value and threshold counter value is 500. So when we start the timer peripheral, the var counter value will start incrementing from 0, 1, 2, 3 till it reaches the maximum 1000 value, and in between reaching to the 1000 value, it will be having the value equal to 500, that is threshold counter, and at this point the microcontroller state value will change. Let's say it changes to the low value, and from 500 to 1000 it will be then having a low voltage signal, and on reaching to the 1000 value, its var counter value will reset to 0 and it will be the microcontroller pin value, it's changed to high voltage. So now from 0 to 500 value, it will be having a high voltage signal, and then on reaching to the 500, the microcontroller pin value then changed to the low. So you will see that a high and low voltage signals are continuously being generated using these counter values. So these counters work together to change the microcontroller pins values simultaneously, which results in generation of series of high and low voltage signals one after the other, forming a digital PWM signal.